Welcome to Sleepy Crimes. I am Anna, your host. Tonight, we drift into the shadows of Planet X theories. We begin our journey in the late 19th century, a time when the world was lit by the soft, flickering orange glow of gas lamps, and the air carried the faint scent of coal smoke and aged parchment. Imagine yourself stepping into an astronomical observatory of that era. The floorboards beneath your feet are polished oak, dark and cool, creaking just slightly as you walk. The room is vast and circular, dominated by a towering instrument of brass and glass. The telescope reaches upward like a silent sentinel, its heavy metal frame glistening in the moonlight that spills through the open dome. Outside, the world is hushed, wrapped in the velvet embrace of a clear, freezing night. Here, in the silence, the masters of the stars are busy. They are not just looking, they are listening to the rhythm of the cosmos through the language of geometry and gravity. Every scratch of a quill on paper, every click of a gear, is a step closer to a secret that has been hidden since the dawn of time. To understand the mystery of the distant tremor, we must look back to the 17th of March, 1781. It was on this night that William Herschel pointed his telescope at the constellation of Gemini. He was looking for stars, but he found something that moved, a pale greenish disk that refused to stay still. This was Uranus, the first planet discovered with the aid of technology, effectively doubling the size of the known solar system in a single evening. For decades, the world marveled at this new frontier. But as the years passed, the excitement turned into a quiet, gnawing frustration for the mathematicians who tracked its path. Uranus was not where it was supposed to be. It seemed to wander, drifting slightly off its calculated course, as if it were being pulled by an invisible hand. By the middle of the 19th century, the discrepancy had become impossible to ignore. It was a cosmic riddle, a ghost in the clockwork of the heavens that demanded an answer. The answer seemed to arrive in 1846. Two brilliant minds, Urbain Le Verrier and John Couch Adams, independently realized that the strange behavior of Uranus could be explained by the presence of yet another planet lurking even further out in the darkness. They used nothing but the laws of gravity to predict exactly where this intruder should be. When the telescope was finally pointed at the predicted coordinates, there it was. Neptune, a cold, blue giant. It was a triumph for the human mind, a proof that the universe followed rules we could decipher. The scientific community exhaled a collective sigh of relief. The mystery of Uranus's wobble was surely solved. But as the years rolled into the late 1800s, a new generation of astronomers began to look closer at the data. They realized that even with Neptune's gravity accounted for, the numbers still didn't quite add up. There was a tiny, persistent leftover, a residual tremor in the orbit of Uranus that shouldn't be there. Imagine the meticulous work of these late 19th century scholars. They sat in pools of candlelight, surrounded by stacks of observational logs spanning over a century. They checked and double-checked the mass of Jupiter, the pull of Saturn, and the newly discovered influence of Neptune. Yet the math remained imperfect. Uranus was still being tugged. It was a minute deviation, a fraction of a degree, but in the precise world of celestial mechanics, a fraction of a degree is a mountain of evidence. This was the distant tremor. It felt as though something massive, something dark and silent, was breathing on the edge of the solar system. The air in those cold observatories must have felt electric, with the realization that the map of the heavens was still incomplete. The giant planets we knew were merely the inner circle, and the true darkness beyond held a secret that was pulling on the heart of our sun's family. This unseen force was not a chaotic anomaly. It was a pattern. The way Uranus accelerated and then slowed suggested a specific mass in a specific place. It was as if the solar system was a grand, invisible spiderweb, and a heavy weight had landed on the farthest outer thread, sending vibrations inward to the planets we could see. The astronomers of the late 1880s began to speak in hushed tones of a trans-Neptunian object. They didn't have a name for it yet, but they could feel its gravity. They described it as a hidden titan that had been watching us from the shadows for eons. The search was no longer just about mapping the sky. It was about finding the source of this persistent pull. It was a race to find the one who was shaking the foundations of our celestial understanding. As we close our eyes and imagine those early pioneers, we can almost hear the soft rustle of their charts and the steady ticking of the observatory clocks. They were standing on the edge of a great abyss, looking out into a void where the sun is nothing more than a bright, cold star. The tremor was their only guide, a silent signal across billions of miles of empty space. Tonight, as you settle into your blankets, think of that quiet pull. The universe is much larger than the things we can see, and even the smallest wobble can lead to the greatest discovery. The search for the source of that tremor had only just begun, and the shadows were about to get much deeper. Sleep now, knowing that the stars are being watched, and the mysteries of the deep dark are waiting for the dawn. The year was 1894, when the high desert of Arizona felt the first footsteps of a man who would transform its rugged peaks into a gateway to the cosmos. Imagine the air in Flagstaff at 7,250 feet. It is thin, cold, and carries the sharp, resinous scent of the ponderosa pines that blanket the landscape. Percival Lowell, a man of immense Bostonian wealth and an even more expansive imagination, arrived here not for the gold in the hills, but for the clarity of the heavens. He was a mathematician and a businessman, but in the silence of the Arizona night, he became a watcher. He chose this specific ridge, which he would eventually call Mars Hill, because the atmosphere was steady, and the light of the stars did not dance or flicker as much as it did in the humid lowlands of the east. Here, the universe felt close enough to touch, and Lowell was determined to reach out and pull its secrets into the light. The structure he built was a sanctuary of wood and copper, a grand observatory that housed the famous 24-inch Clark refracting telescope. Can you picture the great white barrel of that instrument? It was crafted by the hands of Alvan Clark and Sons, the finest telescope makers of the 19th century. It stood as a silent, elegant sentinel under the rotating dome, its glass lens polished to a degree of perfection that allowed Percival to peer deeper into the shadows than almost anyone before him. In those early years, his mind was consumed by the red planet, Mars. He spent hours upon hours, his eye pressed against the cold brass of the eyepiece, sketching intricate webs of lines he believed were canals built by an ancient, thirsty civilization. While the rest of the scientific world remained skeptical, Percival was undeterred. He was a man who lived within his own vision, a man who saw order where others saw chaos, and soon his gaze would shift from the red dust of Mars to a much darker, much deeper mystery at the very edge of our solar system. By the time 1905 arrived, Percival had become haunted by a ghost in the celestial machinery. He looked at the orbits of Uranus and Neptune, the icy giants we thought we understood. But the numbers did not add up. There was a slight wobble, a lingering tug that suggested something massive was lurking further out in the eternal dark. He called this invisible specter planet X to Percival. It was not merely a possibility. It was a mathematical necessity. He believed that the gravity of this unknown world was reaching across the void, pulling at the known planets with an invisible hand. To find it, he needed more than just a telescope. He needed the painstaking power of mathematics. He hired a team of human computers, most notably a brilliant woman named Elizabeth Langdon Williams. Together, they sat in the quiet rooms of the observatory, surrounded by the smell of old paper and graphite, using a mechanical device known as the millionaire calculating machine to crunch thousands of numbers, hoping to predict exactly where this ninth world might be hiding. The search was an arduous, repetitive labor of love. Every night, the astronomers on Mars Hill would expose large glass photographic plates to the sky, capturing the frozen light of thousands of stars. The next day, those plates would be compared, one by one, looking for a single point of light that moved differently than the others. It was like searching for a specific grain of sand on a vast, dark beach. Percival poured his personal fortune into the hunt, upgrading his equipment and pushing his staff to work through the freezing winter nights of the Arizona high country. He felt the weight of the search on his shoulders, a race against time and against rival astronomers like William Pickering. The pressure began to manifest in his health. The man who had once been a vibrant traveler and diplomat was now a pale figure often confined to the mountain he had claimed as his own. He grew restless, his letters filled with a sense of urgency that bordered on obsession. The ninth planet was out there, he was sure of it, and he could not rest until he saw its face. As the years stretched toward 1916, the world outside Flagstaff began to crumble under the weight of the First World War. Percival, a dedicated pacifist, was deeply saddened by the violence across the ocean. The stress of the global conflict, combined with the mounting frustration of his unsuccessful search, began to take a heavy toll. He published his memoirs on the trans-Neptunian planet in 1915, a final testament to his mathematical certainty, but the physical discovery remained elusive. On the evening of November 12, 1916, at the age of 61, the man on the hills suffered a massive stroke in his home near the observatory. He died before the sun rose the next morning. He left behind a legacy of curiosity, a mountain of data, and a search that had stalled just inches from its goal. He never knew that his telescopes had actually captured images of the planet he sought, but it was too faint and too small for his weary eyes to recognize. He was buried there, on Mars Hill, in a beautiful mausoleum with a blue and purple stained glass dome, just steps away from the telescope that had been his window to the infinite. The year was 1929, when a young man named Clyde Tombaugh arrived at the Lowell Observatory in Flagstaff, Arizona. He was only 24 years old, a self-taught astronomer from a farm in Kansas who had spent his teenage years building his own telescopes out of discarded farm machinery and old car parts. Clyde had a rare gift for patience and an eye that could find patterns where others saw only chaos. He had been hired by the director, Vesto Slipher, to pick up the torch that Percival Lowell had dropped over a decade earlier. The search for Planet X had become something of a ghost story at the observatory, a lingering promise of a giant world hidden in the velvet blackness beyond Neptune. As Clyde stepped onto the grounds of Mars Hill, the air was thin and bitingly cold, scented with the sharp, clean aroma of ponderosa pines and the faint, metallic tang of the silver-domed telescopes that watched the heavens. Clyde's days were spent in a quiet, windowless room, hunched over a heavy, brass-framed machine known as a blink comparator. This device was a marvel of mechanical precision and optical monotony. It held two large glass photographic plates, each capturing the same section of the night sky, but taken several nights apart. Through a single eyepiece, Clyde would watch as the machine rapidly switched the view between the two plates, 3 times every second. Click, click, click. The sound was rhythmic, almost hypnotic, echoing through the silent halls of the observatory. If an object was a distant star, it remained frozen, a tiny, unmoving pinprick of white light. But if an object was a planet, it would appear to hop back and forth against the stationary background, a tiny dance across the darkness. For months, Clyde sat in that chair, staring at hundreds of thousands of stars, his eyes burning from the strain, looking for one single flickering speck that refused to stay still. The breakthrough came on the afternoon of February 18th, 1930. Outside, the Arizona sky was overcast and gray, but inside the laboratory, Clyde was meticulously comparing 2 plates taken in the constellation of Gemini during the previous month of January. Specifically, he was looking at images from January 23rd and January 29th. At exactly 4 o'clock in the afternoon, his heart began to race. A tiny dot, no larger than a grain of salt, was jumping. He switched the plates back and forth, over and over again, the mechanical shutter clicking like a heartbeat. He measured the distance the speck had moved. It was only 3 millimeters over the course of 6 days. This slow, deliberate crawl confirmed it was far beyond the orbit of Neptune. He reached for a third plate, a lower-quality image from January 21st, and there it was again, exactly where the math suggested it should be. The young man from Kansas stood up, took a deep breath of the stale, cool air, and walked down the hall to the director's office. "I have found your Planet X," he said, his voice steady despite the adrenaline coursing through him. The news was kept secret for several weeks as the astronomers at Lowell verified the discovery. They watched the speck night after night, confirming its orbit and its lonely path through the outer reaches of the solar system. Finally, on March 13, 1930, the anniversary of Percival Lowell's birth and the discovery of Uranus, the announcement was telegraphed to the world. The celebration was immediate and grand. Headlines across the globe heralded the discovery of a ninth planet, a monumental achievement that seemed to validate Percival's lifelong obsession. They named it Pluto, a suggestion that came from an 11-year-old girl in England named Venetia Burney, who thought the name of the Roman god of the dark underworld was fitting for a world so far from the sun's warmth. The first 2 letters of the name, P and L, were also a subtle tribute to Percival Lowell himself. For a brief moment, it seemed the mystery of Planet X had been solved, and the heavens were finally complete. But as the initial excitement faded, a chilling realization began to settle over the scientific community. According to Percival Lowell's complex mathematical predictions, Planet X was supposed to be a massive gas giant, a world 6 times the mass of Earth that was powerful enough to pull on the orbits of Uranus and Neptune with a gravitational tug of war. However, the object Clyde had found was hauntingly faint. It was a tiny, frozen speck of light, far dimmer than any giant planet should be at that distance. As astronomers calculated its size, they realized with growing unease that Pluto was small. It was much smaller than Earth, perhaps even smaller than our own moon. It was an icy, lonely rock, not the Titan they had been searching for. The math that had led them to this exact spot in the sky suggested a monster, but the telescope had revealed only a ghost. If Pluto was too small to affect the orbits of the other planets, then why had Percival's calculations pointed directly to its location? The discovery of Pluto was a triumph of human persistence, yet it left a void that was perhaps even more unsettling than the one it filled. The celebrates turned into whispers of doubt. If this tiny, frozen speck wasn't the Planet X that Lowell had envisioned, then the true monster might still be out there, hiding further in the shadows, waiting for its turn to be seen. The search had found a planet, but it had not found the answer. As Clyde Tombaugh returned to his telescope and his blink comparator, the silence of the Arizona nights felt heavier than before. He had found a new world, but the ghost of Percival's giant still haunted the edges of the maps, a shadow that refused to disappear. The story of the frozen speck was only the beginning of a much deeper, much colder mystery that would span the next century. The transition from the triumph of the 1930s into the quiet, reflective years of the 1950s brought a subtle but profound shift in the halls of astronomy. The discovery of Pluto had been a moment of global celebration, a confirmation that Percival Lowell's restless spirit had been right all along. But as the years pressed on and the ink on the discovery announcements dried, the numbers began to tell a far more complicated story. Astronomers were no longer looking at the sky with the same simple wonder. They were looking at it with a growing sense of mathematical dread. Pluto was supposed to be a giant, a massive world capable of tugging on the orbits of Uranus and Neptune with the strength of 7 Earths. Yet, as telescopes grew more refined and observations more precise, it became clear that Pluto was a featherweight. It was a tiny, frozen speck that lacked the gravity to even nudge its neighbors, let alone pull them off course. This realization did not end the search. Instead, it reignited it with a quiet, desperate intensity. The 1950s were an era of silent observatories and long, lonely nights. Imagine the scene at the Lowell Observatory or the United States Naval Observatory during this time. The air is thin and cold, smelling of mountain pine, and the sharp, metallic scent of the telescope's heavy gears. There are no glowing computer screens here yet, only the steady, rhythmic clicking of the blink comparator. This machine was the heart of the search, a mechanical bridge that allowed an astronomer to flip back and forth between two photographic plates taken days apart. If a dot moved, it was a planet. If it stayed still, it was just another distant, unmoving sun. But in this decade, the movement they sought was frustratingly absent. The astronomers of the mid-century were haunted by what they called the residuals. These were the tiny, nagging differences between the predicted path of a planet and its actual position in the velvet dark. The giant planets were drifting, and no one knew why. These residuals were the true whispers from the void. They suggested that something was out there, something immense and hidden, still waiting to be named and mapped. The calculations of the era confirmed a missing mass problem that felt like a physical hole in the fabric of the solar system. If Pluto was not the giant they had been promised, then where was the real monster? The search through the 1950s and 60s became a quiet but persistent hunt, a slow grinding of the gears of science. It lacked the loud, publicized race of the previous generation, becoming instead a monastic process of elimination. Astronomers like Clyde Tombaugh continued to scan the ecliptic for over a decade after his first discovery, his eyes growing weary from the endless fields of cold, distant stars. He was looking for a giant that refused to be seen, a phantom that seemed to play a game of hide and seek across millions of miles of empty space. The physical texture of the search was one of grueling patience and sensory isolation. Each photographic plate was a heavy sheet of glass, coated in a light-sensitive emulsion that had to be handled with extreme care in the dim, blood-red light of the darkroom. The astronomers would spend hours hunched over these plates, their breath frosting in the unheated domes as they worked through the winter months. They were looking for a needle in a haystack made of billions of other needles. By the time the 1960s arrived, the mystery had only deepened as technology began to shift. Early computers, massive, room-filling machines that hummed with the heat of thousands of vacuum tubes, were brought in to process the orbital data with a precision humans could not match. These mechanical brains confirmed what the human ones already feared. The giant planets were still misbehaving. Uranus was slightly ahead of its predicted path, tugged by an invisible hand that the math could feel, but the eyes could not see. There is a specific kind of loneliness in searching for something that the mathematics of the universe says must exist, but the light of the stars refuses to reveal. During the 1960s, this feeling permeated the community of outer planet researchers. They began to theorize about a world that was perhaps darker than coal, or tilted so steeply that it spent most of its time far above or below the plane of the other planets. They called it the missing mass problem, a term that would later find a home in the study of dark matter and distant galaxies, but for now, it was a local, solar crisis. The search was no longer just about the glory of discovery. It was about the integrity of physics itself. If there was no Planet X, then our understanding of gravity or the very weights of the planets we already knew might be fundamentally flawed. The stakes were invisible, yet they were incredibly high, resting on the motion of a world that remained a ghost. As we drift deeper into this mid-century silence, we must imagine the weight of those unanswered questions. The world was looking toward the moon, toward the bright flares of the Apollo missions and the new, noisy frontier of the space age. But the astronomers looking outward, beyond the reaches of the sun's warmth, were stuck in a loop of calculations and glass plates. They were the keepers of the missing mass, the guardians of a secret that the universe seemed determined to keep hidden in the deep freeze of the outer rim. The giant was out there, they were sure of it. It was a presence felt through a gravitational tug, a shadow cast across the ledger of the solar system. The search was a vigil, a quiet watching of the horizon where the light of the sun fails and the true dark begins. And so, the 1960s drew to a close with the phantom giant still lurking in the void, a whisper that refused to become a shout, leaving the door open for the heartbreaks of the decades yet to come. But while the eyes of science were fixed on the lunar dust and the cold mathematics of orbits, a different kind of light was beginning to flicker from the dusty shelves of antiquity. The year was 1976. The world was caught in a strange transition, a moment where the rigid certainties of the mid-century were beginning to soften and blur. In the United States, the bicentennial celebrations had left a lingering sense of reflection on the past, but the public's imagination was drifting far beyond the 200 years of a single nation. People were hungry for a different history, one that could explain the gaps in our understanding of who we are and where we came from. In the quiet corners of libraries and the dim glow of study lamps, a new narrative was being woven, one that would marry the high-stakes hunt for Planet X with the crumbling clay of ancient Sumer. In that pivotal year of 1976, a scholar named Zecharia Sitchin published a book that would become a cornerstone of modern alternative history. It was titled The 12th Planet. Sitchin, a man born in Azerbaijan and raised in Palestine, claimed to have unlocked a secret language hidden within the cuneiform tablets of the Sumerians. He didn't just see myths or metaphors in those ancient etchings. He saw a literal history of our solar system that mainstream science had somehow forgotten. He spoke with a quiet, unwavering authority, suggesting that the Sumerians, who lived 6,000 years ago, possessed astronomical knowledge that should have been impossible for their time. They knew about the blue-green hue of Uranus and the watery depths of Neptune, planets that our modern telescopes wouldn't confirm for thousands of years. But most importantly, Sitchin claimed they knew about a ghost in the machine, a hidden world they called Nibiru. Imagine a planet that does not follow the nearly circular paths of its siblings. Instead, imagine a world on a violent, elongated elliptical orbit, like a comet carved from the dark matter of the outer void. Sitchin described Nibiru as the 12th planet, a count that included our sun, our moon, and the 9 known planets of the time, including Pluto. This world, he argued, only visits our inner neighborhood once every 3,600 years. For the vast majority of its life, it is a lonely wanderer, drifting far beyond the reach of the sun's warmth, hidden in the shadows where our modern astronomers were desperately searching for Planet X. To Sitchin, the hunt for a mathematical anomaly wasn't a search for something new, but a rediscovery of something ancient. He called it the planet of the crossing, a celestial body that brings upheaval and transformation every time it swings back toward the fire of the sun. But Sitchin's theory went deeper than just celestial mechanics. He introduced the world to the Anunnaki. In the Sumerian tongue, the word translates roughly to those who from heaven to earth came. According to his interpretation, these were not gods in the spiritual sense, but flesh and blood travelers from Nibiru itself. He painted a picture of a dying world, a planet whose atmosphere was thinning, leaking its precious warmth into the vacuum of space. The Anunnaki, he claimed, came to Earth 450,000 years ago in a desperate quest for gold. They didn't want it for jewelry or currency, but to pulverize it into a fine dust and suspend it in their skies, creating a golden shield to save their home. This narrative turned our entire history on its head. Suddenly, the gold mines of southern Africa weren't just ancient ruins, but the birthplaces of a cosmic labor force, and we, humanity, were the result of a divine genetic engineering project designed to serve these visitors from the stars. The centerpiece of Sitchin's physical evidence was a small, unassuming object kept in the State Museum of Berlin. It is known as cylinder seal via 243. If you were to hold it in your hand, you would feel the cool, hard surface of the stone carved with meticulous precision thousands of years ago. When rolled across wet clay, it leaves an impression of a seated god, a plow, and most crucially, a celestial map. In the upper left corner, Sitchin pointed to a central sun surrounded by 11 smaller spheres. He argued that this was a complete map of our solar system as seen by the Anunnaki, showing the exact positions of the planets, including the elusive Nibiru. Critics and linguists would later argue that the central star lacked the wavy lines the Sumerians always used to represent the sun, and that the dots were merely stars in a constellation. But for those listening in the late 70s, the seal was a smoking gun, a tangible link to a shadow planet that had been watching us from the dark for millennia. As the 1970s faded into the 80s, the two worlds of Planet X began to bleed into one another. The cold, academic search for a gravitational tug on Uranus was no longer just a matter for astronomers in white coats. It had been infused with the scent of incense and the weight of ancient stone. The name Nibiru began to circulate in the same breath as the mathematical predictions of Lowell and Pickering. For the conspiracy theorists and the seekers of hidden truths, the evidence was no longer just in the stars. It was in our blood, in our myths, and in the silence of the ancient ruins. The Sumerian shadow had fallen across the path of modern science, and the hunt for the 10th planet was about to become something much more personal and much more terrifying. The question was no longer just where is it, but when will it return, and what will it demand of us when it finally emerges from the deep black night? The year was 1983, a time when the world was looking upward with renewed curiosity and a touch of lingering Cold War anxiety. On a crisp morning in late January, specifically the 25th of that month, a rocket roared to life at Vandenberg Air Force Base in California. Atop that pillar of fire sat a silent, sophisticated pioneer. The infrared astronomical satellite, or IRAS. This was no ordinary telescope. While the great glass lenses of Earth were limited by the visible light that could penetrate our atmosphere, this machine was built to see the invisible. It was equipped with an infrared eye, a sensor so sensitive that it had to be kept in a state of impossible cold. To function, its internal systems were bathed in a steady supply of liquid helium, chilling the telescope to nearly absolute zero. This extreme cooling allowed it to detect the faint, ghostly heat signatures of objects that emitted no light at all. For 10 months, it drifted in a polar orbit, a lonely sentinel peering into the ink-black depths of the cosmos, mapping a universe that had remained hidden since the dawn of time. Imagine the silence of that mission. While we went about our lives on the surface, moving through the neon-lit 80s, the satellite was whispering back to Earth in a language of thermal data and electronic pulses. It was searching for the birth of stars and the centers of distant galaxies, but it was also scanning our own backyard. Infrared light is the language of heat, and in the freezing vacuum of space, even a cold, dark planet radiates a tiny amount of energy. The scientists at the Jet Propulsion Laboratory and across the ocean in the United Kingdom and the Netherlands were prepared for many things. They expected to find thousands of new stars and perhaps a few comets. They did not expect to find something that would stop them in their tracks, something located right on the edge of the familiar constellation of Orion. This was the hunter's domain, a region of the sky known for its brilliant stars and the Great Nebula, but hidden within its western reaches was a phantom that the infrared eye could not ignore. As the data began to trickle in during the latter half of the year, a particular signature caught the attention of the mission's chief scientists, Jerry Neugebauer and James Houck. It was a point of heat, incredibly faint but undeniably there. When they first mapped it, they noted its position near Orion. It was cold, only about 40 degrees above absolute zero, which meant it wasn't a star. It was far too cold for that, but it was also strangely persistent. In a second sweep 6 months later, the object appeared to be in the exact same spot. This was the detail that sent ripples through the scientific community. If it were a comet, it should have moved significantly across the sky. If it were a nearby asteroid, it would have drifted. Yet, here was a massive heat source, appearing as a solid point, seemingly anchored in the darkness. The team began to calculate its distance and size, and the numbers they whispered behind closed doors were staggering. They were looking at something potentially as large as Jupiter, and it was close. The atmosphere in the laboratories must have been electric, a mixture of scientific triumph and dawning realization. Could this be the legendary 10th planet? The gravitational ghost that had haunted astronomers for a century seemed to have finally stepped into the light, or rather, the heat. It was estimated to be perhaps 50 billion miles away. In the grand, sprawling scale of the galaxy, that is a mere stone's throw. It was close enough to be considered a part of our own solar system, yet far enough to have remained a total mystery to every telescope ever built. Neugebauer was cautious, as any great scientist must be. He knew that the data could be interpreted in several ways. Perhaps it was a distant galaxy shrouded in so much dust that its light couldn't escape. Perhaps it was a protostar that had never ignited. But the possibility of a giant, dark planet lurking just beyond Pluto was the theory that took hold of the imagination. It was the one possibility that felt like a bridge between the cold calculations of physics and the ancient myths of a hidden world. On December 30th, 1983, the secret spilled out of the academic halls and onto the front pages of the world's most influential newspapers. The Washington Post carried a headline that would become a cornerstone of conspiracy theories for decades to come. It read, "Possibly as large as Jupiter, mystery heavenly body discovered." The article, written by Thomas O'Toole, described the object as a celestial mystery so profound that astronomers didn't know if it was a planet, a giant comet, or a nearby protostar. The public reaction was instantaneous. For the average person, the distinction between a protostar and a planet was minor compared to the sheer weight of the word discovered. For the first time, a reputable mainstream news source was reporting that there was something huge and unknown on the doorstep of our solar system. The infrared eye had seen something that our eyes could not, and the world began to wonder if we were truly alone in our local corner of the void. The headlines didn't just report a discovery, they reignited a fire. For those who had been following the breadcrumbs of Planet X for years, this was the smoking gun. It wasn't just a theory anymore. It was a physical entity detected by a multi-million-dollar satellite. However, even as the world gasped at the news, the liquid helium cooling the satellite was finally running out. On November 21st, 1983, shortly before the massive news break, the satellite had gone warm and blind. It had finished its mission and fell silent, leaving the scientists with a mountain of data and a single, tantalizing mystery near Orion. They had the evidence, but the eye that saw it was now closed forever. The debate was no longer about whether the satellite had seen something, it clearly had, but about what that something truly was. As the year turned into 1984, the scientific community began a slow, quiet walk back from the sensational headlines. But for the rest of the world, the seed of doubt had been planted. The dark world was out there, and we had finally felt its heat. The morning of December 30th, 1983, arrived with the particular stillness of a winter's end. In the quiet neighborhoods of Washington, D.C., and across the nation, the ritual was the same. The rustle of a heavy newspaper being retrieved from a frosted porch. The sharp scent of fresh ink meeting the steam of a first morning coffee. But that day, the front page of the Washington Post held a weight that felt different. It was a story written by Thomas O'Toole, a veteran science reporter who knew the power of a well-placed word. The headline was not a suggestion. It was a revelation that seemed to vibrate with a secret frequency. It read, "Possibly as large as Jupiter." Underneath, a mystery heavenly body was described as having been found in the direction of the constellation Orion. For a world already fascinated by the unknown, This was the moment the shadow finally took a shape. It was as if the universe had blinked, and in that split second, we had seen something we weren't supposed to see. The details provided in that article were enough to keep anyone awake at night, staring at the ceiling and wondering what moved in the dark. The discovery came from the infrared astronomical satellite, known as IRAS, a joint project between the United States, the Netherlands, and the United Kingdom. This satellite was different from the telescopes of the past. It didn't look for the light we could see with our eyes. Instead, it looked for heat. It scanned the sky for the faint, warm signatures of objects that cast no light of their own, drifting in the absolute cold of deep space. Jerry Neugebauer, the chief scientist for the project, was quoted in a way that felt hauntingly honest. He told the reporter, "All I can tell you is that we don't know what it is." In the world of high-level astrophysics, such a direct admission of ignorance is rare. It suggests an anomaly so profound that the usual labels, comet, asteroid, or star, simply do not fit the evidence at hand. Think about the atmosphere of that time. The early 80s were a period of intense curiosity and a growing sense that the government knew more than it was letting on. When James Houck of Cornell University, another member of the science team, spoke about the object, he added to the mounting tension. He noted that if the body was truly as close as 50 billion miles, it would be the nearest heavenly body to Earth beyond the outermost planet, Pluto. He admitted that if it were that close, he didn't know how planetary scientists would even begin to classify it. This wasn't just a distant speck of light. This was a presence, a silent, cold giant lurking on the doorstep of our solar system. The article described it as being so cold that its temperature was no more than 40 degrees above absolute zero, which is roughly 456 degrees below zero on the Fahrenheit scale. It was a ghost made of frozen gas and mystery, found twice by the satellite as it scanned the northern sky. But as quickly as the fire was lit, the cooling began. In the months that followed that explosive headline, the narrative started to shift in a way that felt, to many, like a choreographed retreat. NASA began to release follow-up papers and statements that sought to reclassify the mystery. The giant object, once teased as a possible 10th planet or a nearby protostar, was suddenly being described as something far less sensational. Scientists began to suggest that what the satellite had actually seen were distant, ultraluminous infrared galaxies, or perhaps filamentary structures known as galactic cirrus. Essentially, wisps of cosmic dust. To the academic community, this was simply the process of science, observing, questioning, and refining data. But to the public, who had already seen the words possibly as large as Jupiter burned into their minds, the explanation felt like a bucket of cold water meant to douse a truth that had become too hot to handle. The walk back fueled 1,000 theories. Why had the initial excitement been so palpable? Why had the scientists been so certain of the object's proximity in the beginning, only to push it millions of light years away months later? In the shadows of the burgeoning internet and the hushed corners of late-night radio, the theory of a cover-up took root. It was suggested that the satellite had indeed found Planet X, a massive, returning world that posed a threat to Earth. The theory proposed that once the true nature of the discovery was realized, a curtain of silence was drawn. The distant galaxy explanation was viewed by some not as a correction, but as a distraction. They pointed to the fact that the satellite had run out of its super-cold helium coolant shortly after the discovery, effectively blinding our infrared eyes just as things were getting interesting. It was a timing that seemed almost too convenient. Even now, decades later, that single article from 1983 remains the cornerstone of the Planet X mythos. It is the piece of evidence that believers return to when they feel the weight of modern skepticism. They see it as a brief window of transparency before the doors were locked. When we look back at the text of that day, we see the fingerprints of a different era, an era where the sky felt a little more mysterious and the distance between the stars felt a little shorter. Whether it was a misidentified galaxy or a planet that prefers to stay hidden, the headline remains. It is a haunting reminder that sometimes the most significant things are found not in what we can see, but in the heat of what remains invisible. The shadow in Orion hasn't gone away. It has simply moved into the quiet spaces of our collective memory, waiting for the next time we dare to look up and wonder. The United States Naval Observatory in Washington, District of Columbia, is a sanctuary of white domes and rolling hills. In the late 1970s, this was the domain of Robert Sutton Harrington, a man of quiet authority and rigorous intellect. As a supervising astronomer, he navigated the deep currents of our solar system with the focus of a seasoned mariner. To many, he was the true admiral of the stars. Harrington believed the celestial maps were incomplete, harboring a secret that lay just beyond the reach of the most powerful lenses of his era. Harrington's journey into the heart of the Planet X mystery intensified in 1978. While working alongside James Christie, he helped confirm the existence of Charon, the largest moon of Pluto. This discovery allowed him to calculate Pluto's true mass with startling accuracy. Pluto was far too small to exert the gravitational influence required to perturb the orbits of Uranus and Neptune. The math was clear and unyielding. If Pluto was not the cause of the wobbles in the outer reaches, then something else was. An unseen colossus was pulling at the edges of our known world. Driven by this mathematical certainty, Harrington dedicated years to refining his search. He proposed a world that was 3 to 5 times the mass of the Earth, locked in a highly eccentric and elongated orbit. Most intriguing was the angle of this path. While most planets stay within a relatively flat plane, Harrington's models suggested this intruder was tilted at 30 or 40 degrees. This meant it spent centuries diving into the deep void below the solar system before soaring back up. He visualized a dark, icy giant retreating into the absolute blackness of the outer reaches. The narrative took a surreal turn in 1990 when Harrington met Zecharia Sitchin, the researcher who claimed ancient Sumerian texts described a hidden planet called Nibiru. In a filmed interview, the two discussed the striking similarities between modern astronomical models and ancient myths. Harrington did not dismiss these unconventional theories. Instead, he noted with scholarly fascination that his calculations for a tilted intruder planet matched the descriptions of Nibiru almost perfectly. He sat before the camera, composed and professional, admitting that the evidence for a 10th planet was becoming undeniable. By 1991, Harrington believed he was closing in on the target. His data suggested the planet would be most visible from the southern hemisphere as it approached the ecliptic. He traveled to the Black Birch Observatory in New Zealand, standing on a windswept ridge under violet skies. The air there was thin and freezing, the stars vibrating with a clarity found nowhere else. Night after night, he peered through an 8-inch telescope, searching for a moving speck among millions of lights. He was hunting a ghost that had evaded discovery since the dawn of humanity, convinced he was on the precipice of the greatest find in history. However, the search ended with a sudden and tragic finality. As Harrington reportedly prepared to announce his findings, he was diagnosed with an aggressive form of esophageal cancer. On January 23, 1993, the Admiral of the Stars passed away at the age of 50. He was gone within months, leaving behind a desk cluttered with unfinished equations and a legacy of profound mystery. While the medical cause was clear, the timing felt suspiciously perfect to those who believed the government was desperate to keep Planet X a secret. The mystery deepened just months before his death, when the scientific community revised the mass of Neptune using data from the Voyager 2 mission. This adjustment allegedly accounted for the orbital discrepancies, effectively ending the official hunt for Planet X. To the establishment, the case was closed by a simple decimal point. But for those who followed Harrington's work, The correction felt like a convenient way to bury a discovery that was becoming too dangerous to ignore. Why did the answers change exactly when Harrington was peering through his lens in New Zealand? The official record cites a tragic disease, but the legend suggests he was silenced. Today, Robert Harrington is memorialized by a lonely asteroid named 3216 Harrington, drifting silently in the void. The halls of the Naval Observatory remain quiet, yet the questions he raised still echo in the darkness. Was he chasing a mathematical phantom, or was he a pioneer who was stopped just before the finish line? We are left with the cold mountain air of New Zealand and the unblinking light of the stars. The Admiral has left the bridge, and his 10th planet remains a shadow, hidden in the velvet blackness of space, waiting for someone else to look up and wonder. The memory of Robert Harrington and his lonely asteroid fades into the deeper quiet of the late 20th century, leaving behind a void where a planet should have been. For decades, the hunt for Planet X was considered a pursuit for the eccentric, a ghost story told in the margins of serious science. But the universe has a way of leaving footprints even when it refuses to show its face. We move now to the year 2016, to the sun-drenched campus of the California Institute of Technology in Pasadena. Here, the tools of the hunt have changed. No longer are we squinting through glass lenses at the cold mountain air. Instead, the search has moved inside the humming silence of high-powered computers, where the physics of the entire solar system can be compressed into a single, glowing screen. In a quiet office, we find two men who would become the modern architects of this mystery. Mike Brown, a man often teased as the person who killed Pluto, and Konstantin Batygin, a young and brilliant theorist with a mind for the complex rhythms of gravity. At first, they were skeptics. They did not set out to find a new world. In fact, they were trying to prove that one did not exist. They wanted to show that the strange orbits of the most distant objects in our solar system were just a coincidence, a trick of the light, or a statistical quirk. But as they layered their data, the math began to speak in a voice they could not ignore. It was a whisper at first, a tiny discrepancy in the paths of 6 distant, icy rocks far beyond the orbit of Neptune. Imagine these 6 objects as tiny, frozen wanderers, billions of miles from the sun. One of them is Sedna, a world of deep red ice that takes 11,000 years to complete a single circle. In a normal, empty sky, these wanderers should be scattered like seeds in the wind, their paths crossing at random angles. But Mike and Konstantin noticed something unsettling. These 6 objects were all clustered together. They were all tilted at the same angle, pointing toward the same patch of sky, as if they were being shepherded by an invisible hand. The mathematical probability of this happening by pure chance was 1 in 15,000. It was a 5 sigma event, a statistical wall that suggested something massive, something hidden, was forcing them into formation. The ghost was no longer a smudge on a plate. It was a mathematical necessity. They began to run simulations, creating thousands of digital solar systems to see what could cause such a perfect alignment. They tried adding small asteroids. They tried adjusting the mass of the known planets, but nothing worked until they introduced a phantom. They placed a massive world, 10 times the weight of our Earth, into the dark outskirts of their model. This world was not a small rock like Pluto. It was a giant, perhaps a mini Neptune, carved from gas and ice. In their simulation, they watched as this giant world took its place, orbiting 20 times farther from the sun than Neptune itself. As the digital years turned into billions, the phantom began to exert its will. Its gravity reached out like a long, slow tide, pulling the smaller objects into the exact orbits that Mike and Konstantin saw through their telescopes. The math was perfect. The ghost was real. This realization changed everything. In January of 2016, they went public with their findings, calling it Planet 9. They described a world that reigns over a kingdom of ice, so vast it takes nearly 20,000 years to make a single journey around our sun. It is a world of permanent twilight, where the sun is just a bright star, no more significant than the others. Can you feel the coldness of such a place? A massive, dark sphere drifting through the absolute zero of the inner Oort cloud, unseen by any human eye, yet its presence is felt by everything around it. It is the ultimate mathematical ghost, a titan whose existence is proven not by sight, but by the way it makes the rest of the solar system dance to its heavy, slow rhythm. Since that announcement, the hunt has been revitalized with a fervor not seen since the days of Percival Lowell. But this time, we aren't just looking for a needle in a haystack. We are looking for a needle we have already weighed and measured. We know how heavy it is. We know the shape of its path. We know the way it tugs at the edge of our reality. Astronomers around the globe have turned their most powerful sensors toward the regions of space Mike and Constantine identified, searching for the faint, infrared glow of a planet that has been hiding in plain sight for billions of years. It sits there, in the deep dark, waiting for our technology to finally catch up with the truth of the numbers. The mathematical ghost has a home now, a set of coordinates in the mind, even as it remains a mystery to the lens. We are closer than we have ever been to touching the face of the unknown. The hunt for a hidden world began in the silent chill of observatories, through the polished glass of telescopes, and the meticulous scratching of pens on parchment. But as we drifted into the late 1990s, the search shifted from the mountaintops to the glowing, dusty corners of suburban bedrooms. Imagine the scene: the low, rhythmic hum of a bulky desktop computer and the scratchy, discordant symphony of a dial-up modem connecting to a world unseen. This was the birth of the digital fringe, a place where the search for Planet X would be stripped of its scientific rigor and redressed in the robes of prophecy and paranoia. In this dim, electronic light, the rogue planet was no longer just a mathematical possibility. It became a looming shadow, a harbinger of the end times that anyone with a keyboard could track from their own home. The cold, objective vacuum of space was suddenly filled with the static of 1,000 human voices, all whispering of a coming storm. In 1995, a woman named Nancy Leader founded a website called Zeta Talk. The internet was still in its infancy, a landscape of simple text and flat colors, yet through this portal, she claimed to be in communication with beings from the Zeta Reticuli star system. She spoke of a device, a biological implant nestled within her brain, that allowed her to receive warnings from these extraterrestrial visitors. They told her of a massive object, a giant planet roughly 4 times the size of our own, that was careening toward the inner solar system. She called it Planet X according to her celestial sources. This visitor would not just pass us by. It would bring the Earth's rotation to a sudden, jarring halt for exactly 5.9 days. She described a world where the magnetism of this passing giant would grab hold of our planet's core, causing the very crust to shift and slide, rewriting the map of our civilizations in a matter of hours. The digital fringe had found its first prophet. The date for this cataclysm was set with chilling precision: May 27, 2003. As that spring approached, the tension in online forums and chat rooms reached a fever pitch. People shared grainy, pixelated images of lens flares and solar reflections, claiming they were photographs of the red planet as it breached our atmosphere. There was a unique kind of dread that flourished in those early message boards, a communal waiting for a disaster that was perpetually just over the horizon. When May 27th arrived and the sun rose and set as it always had, the silence was heavy. But the digital fringe is resilient. Leaders soon announced that the date had been a white lie, a strategic deception meant to fool the global establishment and keep them from declaring martial law too soon. This maneuver didn't scatter her followers. Instead, it deepened the mystery, turning the absence of evidence into a sign that the conspiracy to hide the truth was even larger than they had imagined. As the decade turned, the legend of Planet X underwent a transformation, merging with the ancient whispers of the Sumerian tablets. It took on a new name, Nibiru. This was a term borrowed from the writings of Zecharia Sitchin, who had spent years interpreting clay tablets to tell a story of a hidden world on a 3,600-year orbit. Although Sitchin himself denied that his planet was a bringer of doom, the internet didn't care for such distinctions. By the time we reached the lead-up to 2012, the myth had become a juggernaut. It fused with the ending of the Mayan long count calendar, creating a perfect storm of apocalyptic expectation. YouTube, now a central pillar of the digital experience, became flooded with videos of supposed sightings. Every comet, every strangely shaped cloud, and every optical glitch in a space agency's live feed was offered as proof that the destroyer was finally here, hidden behind the sun and waiting to strike. The human cost of this digital paranoia was staggering and deeply personal. David Morrison, a senior scientist at the National Aeronautics and Space Administration, found himself at the epicenter of a storm he never asked for. His inbox was inundated with thousands of emails from terrified citizens. Some were parents who were too frightened to let their children sleep. Others were teenagers who saw no point in planning for a future that would never come. They asked him why the government was lying, why the satellites weren't showing the truth, and if they should sell everything they owned to prepare for the end. Morrison spent years patiently explaining that a planet of that size would be visible to the naked eye long before it arrived, and that its gravity would have already unraveled the orbits of the outer planets like a loose thread. Yet, for many, the calm voice of science was less convincing than the frantic, high-definition urgency of a conspiracy video. Even after the quiet passage of December 2012, the ghost of Nibiru refused to fade. It simply retreated further into the shadows of the internet, waiting for a new date to cling to. In 2017, a new wave of fear emerged, tied to biblical numerology and the movements of the stars in September and October of that year. The cycle repeats because the digital fringe provides something that the vast, empty cold of space does not: a sense of narrative. To believe in a rogue planet is to believe that the world is small enough to be affected by a single, dramatic event, and that we are special enough to be warned about it. We scroll through the grainy images and the frantic threads, seeking a sign in the pixels. As we move forward into the modern age, the hunt for the real Planet 9 continues in the quiet halls of academia, but on the digital fringe, the rogue planet remains a flickering, terrifying phantom that never truly goes away. Even after the quiet passage of December 2012, the ghost of Nibiru refused to fade. It simply retreated further into the shadows of the outer solar system, away from the apocalyptic prophecies and into the rigorous, hushed halls of modern astrophysics. Today, our gaze is fixed on a specific, wind-swept peak in the Atacama Desert of Chile. Here, atop the Cerro Pachon Ridge, 8,700 feet above the sea, the air is so thin and dry it feels like a cold ghost against the skin. In this high, lonely place, a new titan has awakened. The Vera Rubin Observatory is a silver fortress of technology, waiting for the sun to dip below the horizon so it can begin the most ambitious census of the stars ever attempted. For years, we have whispered about a secret neighbor in the deep. Now, we have finally built the eyes capable of seeing through the indigo velvet veil. Inside the dome, the atmosphere is one of clinical stillness. There is a rhythmic hum of liquid nitrogen cooling the systems, and the smell of ozone hangs in the night air. At the heart of this machine sits a camera the size of a car, a 3.2 gigapixel marvel. Every few nights, this lens will sweep across the entire visible sky, capturing a digital portrait of billions of objects. It is filming a slow-motion movie of our corner of the cosmos. Every night, 20 terabytes of data flow down from the mountain like a digital river, searching for a single point of light that moves with a slow, deliberate gravity, different than the stars behind it. This is the hunt for Planet 9 in its most modern form. We are no longer guessing based on ancient clay tablets. We are mapping the heavy darkness of the outer rim, foot by foot. By 2025, the search has entered a narrow, tension-filled corridor. Astronomers have already ruled out 78% of the regions where this giant could be hiding. We have looked through the data of older surveys, peering into the deep voids, and found nothing but more silence. This leaves the planet only a few places to tuck away. It might be lost against the crowded backdrop of the northern galactic plane, where the thick soup of the Milky Way's own stars makes it nearly impossible to distinguish a planet from a sun. Or perhaps it is simply too faint, reflecting so little light that it registers at a magnitude of 21 or lower, a glimmer indistinguishable from the background noise. Yet, the mathematical models remain stubborn. They point to a world roughly 4.4 times the mass of Earth, a frozen super-Earth shepherding the distant icy rocks of the Kuiper belt into orbits that should not exist. Why does this obsession persist? Why do we find ourselves enchanted by a secret sibling in the twilight? Perhaps it is because a solar system with only 8 planets feels strangely empty, like a house with a locked room. For centuries, we have projected our fears onto the outer dark. Once it was Nibiru, the bringer of cataclysm. Before that, the wandering stars of the ancients. In the modern era, Planet X is the ultimate cosmic mystery. It represents the possibility that even in our own backyard, there is still a grand secret waiting. If found, it will not bring the end of the world, but a new beginning for our understanding. It would tell a story of a chaotic infancy, of planets jostling like giants in a crowded room, and of one brother being cast out into the cold, doomed to wander the edge of the horizon for 10,000 years. There is a profound comfort in the hunt. It reminds us that humanity is a species defined by its reach. We build towers on mountaintops just to catch a few stray photons from a world that has never known a warm day. Whether the Vera Rubin Observatory finds a bright pinprick in its first year, or concludes that the clustering of orbits was merely a statistical illusion, the search has already changed us. It has forced us to look deeper, to sharpen our math, and to acknowledge that the horizon is not a wall, but an invitation. We are no longer afraid of the dark. We are simply curious about what it is hiding. The secret neighbor remains out there for now, a shadow among shadows, waiting for the moment the lights are finally turned on. The silent giant waits there. This is our search. This is our sky. The case rests now. Let the details fade. You are safe. Close your eyes, breathe deeply, and have a good night. Sleep well.